Let's walk through the typical sequence of operation for a chiller or heat pump. The chiller or heat pump is managed by its dedicated unit controller, typically a Carel PC05 Plus or equivalent. The system can be enabled in 3 ways: through the local touchpad interface, via a BACnet command from the building management system, or by a hardwired enable signal. Once the unit receives that enable command, it prepares itself for operation. The first step after enable is to open the evaporator isolation valve, allowing water or glycol to circulate through the unit, and at the same time, controller send pump enabled signal. The controller then checks all safety conditions. This includes the flow switch, phase monitor, high and low pressure switches, and temperature sensors. Only when everything is normal will the unit proceed to the next stage. Depending on the current mode, the controller maintains either a cooling set point or a heating set point. The system is always comparing the actual loop temperature with its target set point and differential. When proper flow is confirmed, either through a differential pressure sensor or a flow switch, and the loop temperature is beyond the set point plus its differential, the unit begins its main operation. Here's what happens step by step. The condenser fan or condenser isolation valve turns on roughly 10 seconds before the compressor. This gives time for airflow or water flow to stabilize. The controller then starts the lead compressor, followed by lag compressors if more capacity is needed. Compressor rotation alternates automatically every 100 or 168 hours to keep operating hours balanced between circuits. The controller constantly monitors return temperature, set point, and deadband, and enables the next compressor only when the delay time between stages has expired. Meanwhile, it keeps an eye on the condensing pressure of the refrigerant, adjusting fan speed or water valve position as needed to maintain proper head pressure. If anything goes wrong, such as low flow, high pressure, low pressure, or a power issue, the controller immediately generates an alarm and shuts down the affected circuit for protection. As system demand increases, the controller brings additional compressors online to meet the load. When demand drops and the set point is satisfied, it begins shutting compressors off one by one. Each compressor must run for a minimum runtime to ensure proper oil return before it can stop. When a compressor shuts down, the condenser fan or modulating valve stops simultaneously, and the evaporator flow control valve closes. Finally, the controller sends a pump disable signal to turn off the associated pump. In systems with inverter-driven fans, fan speed is automatically adjusted using a 0 to 10 volt DC signal to maintain condensing pressure. For water-to-water units, a motorized condensing valve modulates in the same way to stabilize system head pressure. In colder climates, when the ambient temperature drops below 1 degree Celsius, the condenser fans are programmed to run for 30 seconds every 2 hours. This simple routine helps prevent fan shaft freezing during long periods of inactivity. Down once the target set point is achieved. The flow control, evaporator and condenser if there is any, is closed when the unit is off or standby mode. This sequence ensures reliable operation, balanced runtime, and optimal system performance in all weather conditions. So, in summary, the chiller or heat pump starts only when all safeties are normal, brings on compressors in sequence to match load, continuously monitors system pressures and temperatures, and gracefully shuts